So in the last class, guys, we have covered, I hope my screen is visible to all of you. Love, I hope it's visible to you as well, and the others. Right. So in the last class, guys, we have covered basic networking fundamentals. We've gone through the basic definitions of what networking is, what networks are, what are hosts, and what are IP addresses, the properties of IPv4 addresses. Along with that, we have covered the entire range of IP addresses. What's the first IP? What's the last IP? How many IPs do we have in total? Okay, and the entire sequence of IP addresses. Okay, and along with that sequence again, we have the classification of IPs. Okay, there are five classes: class A, B, C, D, and E. And again, in each of those classes, we have some public IPs and some private IPs. Okay, we have covered the ranges in the last session. In today's class, we'll talk about the relevance of each of these classes. Why are they important? And again, why do we have five separate classes? And what's the relevance of each of them? Okay. Before we get started, also, any questions or doubts in the last session? Anyone who's new to the session today who hasn't accessed the sessions earlier? Any questions? Any doubts? Yeah, okay. Assuming there are no questions, so let's get started. In the last session, love, I think I remember you asking how are these 4.3 billion IPs sufficient? Okay, so we'll start the class today with that topic today. So just a second. Now, when you talk about, oh, there's some background disturbance from the microphone. You can mute the mic, and if you have any queries, you can unmute. Okay, perfect. So now the important point to discuss here is again, some of you might have a question. We just have 4.3 billion IPs, right? But the population itself is 9 billion people, and again, close to 9 billion at least, and the number of devices exceeds much beyond that, right? So we could have like much more, like 20, 30, 50 billion, not sure how many devices are there in the entire world today. Okay, but the main question is, how are these 4.3 billion IPs being sufficient for that? Okay, the concept is through something called natting. Okay, so when you have an ISP, guys, let's say this is my ISP here, internet service provider, and I'm using an ISP like Airtel or Act Hibernate or whatever it is. Okay, these ISPs provide you the public IPs. So let's say this is my home here. Okay, and this is another home, any one of your homes here. Okay, and now at our homes we have our respective Wi-Fi routers, and these Wi-Fi routers are connected internally to the intranet devices. Okay, so let's say there are three devices here, and I have the same three devices, let's say here as well. Okay, or some random number of devices. Now, your ISP provides a public IP to each of these connections. Okay, so I could get a completely different public IP, and you would get a completely unique or different public IP of yours. Let's say I'm getting the IP 1.2.3.4, and you're getting the IP 5.6.7.8. So when any of your devices internally in your network want to communicate with the internet, they'll always have to contact your router. They need to connect to your router, and the router transmits the data across two different networks. So from the private intranet network, it sends it to the internet. Okay. So now these devices here are internally connected to your Wi-Fi router wirelessly, right? So these devices here are wirelessly connected, let's say, to your Wi-Fi router. Same thing here as well. Now, an interesting thing to note is these two networks now, these two intranets can have the same private IPs. Okay, so now this IP over here, my router could get something like 192.168.1.0, 192.168. Sorry, 0.1, let's say. Okay, and let's say we have the next device here, which is 192.168.0.2, and then you could have something like 192.168.0.3, and then 0.4. So this is 0.3 and this is 0.4. So when each of these devices wants to communicate with each other, they'll use the private IPs. Okay. And if this device wants to communicate with the internet, it first sends the packet to the Wi-Fi router with the private IP. Then the router shifts the packet to the public IP, and then that public IP is used to access the internet or the ISP. Okay. Now, on the other hand, in this other network as well, you'll have the same exact IPs. So your router could be again, sorry, your home network router could be 0.1. Okay. And then there could be 0.2, 0.3, and 0.4 as well. Okay. So this is, let's say, 0.2, 0.3, and 0.4. Okay. Now, if you notice, you might have a question. How are the IPs same? When they communicate on the internet, there might be a trouble, right? But I think you already know the answer for this, why there would be no conflict. Because when any traffic reaches the internet, it always happens on the public IP. Okay. So this 192.168.0.2 is connected to this public IP. This 192.168.0.2 is connected to this public IP. So when there is internal communication, these two devices, or I would say these two networks, are two completely unrelated entities. Okay, they cannot communicate with each other directly. Okay, whenever they have to initiate communication over the internet, they'll always communicate with their respective public IPs. Okay, so there's no conflict that if there's a website like facebook.com and if this 0.2 is accessing Facebook and this 0.2 is also accessing Facebook, now your Facebook won't be confused whom to send their data to, because the packets that they are sending will always come from their respective public IPs. Okay. Oh, sorry. Okay. So when this is accessing Facebook, it first sends the packet to the router, and the router shifts it to their public IP. And with that public IP, it reaches the ISP and then the respective server, which is Facebook somewhere here. Let's say there's facebook.com over here. Okay. So when it is reaching Facebook here, it always happens with that specific public IP. Okay. Similarly, when this 0.2 accesses Facebook as well, it sends the packet to the Wi-Fi router. Router sends it to the internet, and then the ISP basically sends it with that public IP. Now, the error or the exhaustion of IPs can happen when these public IPs are exhausted, because every home here now will have a unique public IP, right? So, to overcome that again, what they have done is they have linked public IPv4 addresses to IPv6 addresses. So, there's another concept there, just like how you're linking each of these networks to these unique public IPs. These public IPs again are linked to IPv6 addresses again internally in the ISP's connection. Okay. So they'll have multiple IPv6 IP addresses, which is again each of its own public network. Okay. And then through that, they are able to still sustain the internet on the IPv4 and IPv6 addresses. Okay. So when you talk about private IPs, guys, you can use private IPs in different networks for n number of times, for infinite number of possibilities. Okay. I can have infinite number of networks with the same private IPs, which are not interlinked in any way. Okay. What link happens over the internet is always with the public IPs. And when the day eventually comes when all the IPv4 addresses are exhausted, you'll start directly getting IPv6 addresses for your ISP connections also. In today's world itself, if I go to my browser and if I search for what is my IP, I sometimes get an IPv4 address and sometimes get an IPv6 address also. So if I click on this first link here, you can see I'm getting IPv4 and oh, I don't have IPv6 today. I think in the session yesterday, I got an IPv6 address. Okay. And these can keep changing, alternating every single day. Okay. So there's no necessity that I'll be getting the same public IP tomorrow as well. I can get a completely different public IP tomorrow. Okay. So the ISP can keep changing that every single day. Okay. So that is how we are still able to survive with those 4.3 billion IPs, at least with the IPv4 addresses. Is that clear? Love. And anyone else who had the same question? Hello. Love. Any questions? No, not really. Not every time you disconnect from the internet, your public IP won't exactly change every time you disconnect. But the ISP decides that. So they have something called a lease time. Okay. For that lease time period, your public IP stays the same. And that could be like 24 hours or 48 hours or 72 hours or so. And after that time period, private IP as well. That also has a lease time again. I'm going to explain about private IPs in a topic called DHCP now in a while. So I'll explain there. Okay. But when you talk about the public IPs, as mentioned, that also has a lease time. And the reason why your public IPs have to compulsorily change after every certain hours is because so that people don't start hosting their own services on a unique public IP. So if you have a static public IP, you can actually host your own website from your home. So just so that users don't exploit that, ISPs keep dynamic public IPs. They keep changing it. Okay. Where if you want to host such services, you can request for a static IP. And they'll charge like 300, 400 rupees extra here in India, and then they'll give you a static public IP also, okay, if needed. So, but when you talk about private IPs also, even if you restart the system, it doesn't change automatically. There's a lease time there as well. I'll explain that in a minute. Okay, but I hope I've clarified the question from yesterday. This was your question: how are we capable of connecting these many devices with still just 4.3 billion IPs? I hope that's clarified. Right, perfect. Moving on. Any other questions or doubts up to this point, guys? Others?
Yeah.
Satyajit, Sesh, Tulsi.
Yes. I have one question. Could you switch back to,
Oh, yeah, sure. One second.
yeah. So you're saying 1234 is a public IP address?
Yes, that 1, 2, 3, 4, and that 5, 6, 7, 8, all of those are public
Okay.
IPs.
So what about this 192.168? This is the private IP?
Those are private IPs, exactly.
Okay, so this router has a public IP and private IP both.
Both, yes. On one interface, it will have a public IP, and on the other interface, it will have a private IP. And that's what the
Oh,
router's task is, to transmit data across two different networks. So here in our home network, the Wi-Fi router transmits the data from the public network to the private network and vice versa. Basically from the intranet to the internet and vice versa.
okay. So this 1234 is the like this address is like a static IP?
Not necessarily. It can keep changing as well. As mentioned, those are provided by the ISP, right, Sesh? So those IP
Uh-huh.
addresses can be static if you ask them to keep them static, or they can, by default, they're always dynamic. They keep changing, as
Okay, so
mentioned.
this IP address, public IP address is always changes.
Always changes, always dynamic by default. If you want a static, you can request them a static IP and they'll provide a static IP as well. So in cases like if you have a CCTV camera set up at your home for accessing that CCTV from external, from your phone, from anywhere in the world, that IP should not change. So in such cases, you can request them. I want a static IP for my CCTV setup at home, and then they'll provide you a static public IP, which doesn't change at all. Okay, but they'll charge extra for that.
Mhm. Yeah, thank you.
Okay. Right. So again, Sesh, I think that confusion is arising because you might not have joined the session yesterday, or you might have joined a bit later on. Okay, we have covered all that. Like, why is this 192.168 coming in the private network? Okay, which of these IPs are public? Which of these are private? We have covered all that in the session
Yeah.
yesterday. Okay.
Yes.
So by looking at this range, actually, you can figure out. So if anything starting with 192.168.0.0 and ending with 192.168.255.255 would always be a private IP from class C. Okay.
Right.
Something with 172.16 to 172.31 is private IP in class B. And something with 10 dot, any 10 dot address is private IP in class A. Okay. So excluding these IP addresses, any other IP is a public IP by default. Okay. Is that clear, Sish?
Yeah. Yeah.
Yeah.
Clear.
Perfect, perfect. Moving on. So let's talk about the relevance of these classes, guys, now. So each class is different because it has a different set of network and host portions in it. Class A has one network portion and three host portions. Class B has two network portions and two host portions. Class C has three network portions and one host portion. Class D and Class E have all network portions itself. Okay. So as you're going down the line, the network portions are increasing in number and the host portions are decreasing in number, if you notice. Okay, but what are these network portions and what are these host portions? Okay, what do they signify? Let's talk about that. Okay, so when you talk about network and host portions, guys, to understand this, we'll take the example of class C first, which has three network portions and one host portion. Okay, so I'm going to open up a notepad file first, just a second. And in this notepad file, Just a second. Keep change. Okay. So as mentioned, now in class C, we already know the private IP range starts from 192.168.0.0 and goes all the way up to 192.168.255.255. That's the entire class C private IP range. Okay. And in this entire range, the first three portions are the network portions, and the last portion is the host portion. But what do I mean by that? What does this network portion and what does this host portion individually signify? Now, let's talk about that with the sequence. Okay. So in the last class, we've also learned about the sequence of IPs. So the first IP is 192.168.0.0. If that is the first IP, what would the next IP be? 192.168.0.1. The rightmost octet increments by 1. Next IP, 192.168.0.2. Next IP, 192.168.0.3. Next IP, 192.168.0.4. This goes on all the way up to 192.168.0.254. And then finally, you have 255. Now, what happens after this, guys? If the rightmost octet is fully occupied, what happens then? The rightmost octet cycles back to 0, and the left octet increments by 1. So that 0 becomes 1, and the next 255 becomes 0, right? And after that, you have 192.168, 1, 1, 192.168, 1, 2, 192.168, 1, 3. Sorry, the same pattern repeats again and again. And then you have 192.168, 1255. Right. Now, what I mean by network and host portions are, as long as the host portion is changing, it just indicates a change in the host. So this IP can be assigned to the first host, the second host, the third host, the fourth host, etc., etc. And all of them are belonging to the same network, the 192.168.0 network, which are denoted by the network portions. Okay. So this could be my Wi-Fi router, this could be my laptop, this could be my smartphone, this could be my printer, this could be my other workstation, work laptop, etc., etc. As long as these host portions are changing, it just indicates a change in the host, but still in the same network. And whenever there's a change in the network portion, when the 0 changes to 1, that divides the network completely. So after 0255, you have no more IP addresses to assign in that network. From 10, there's a completely different network now. And from 10 to 1255, that's its own separate network itself. Okay. After 1255, you have 192.168.20, and that starts the next network. So 192.168.20, 21, 22, all the way up to 192.168.2255. That will be the next network, right? And after that, you have a separate network again, which is 30. Okay. So as long as the host portions are changing, it is just a different host, okay, or a different device. Okay, and they can still communicate with each other. But whenever there's a change in the network portion, so when 192.168.0, these three portions, when any of the values from these three portions is changing, the network divides over there, which means now this device 00 and this device 0255 can communicate with each other in this entire range, but they cannot communicate with any other device outside that range. Okay. Similarly, between 10 and 1255 as well, all of these devices can communicate with each other very freely because they belong to one single network. And if you remember the definition of a network is a collection of interconnected devices. They can communicate with each other freely. Okay. And if a device is outside the network, it cannot communicate with them. So 10 can only communicate with all the other IPs on the same network. It cannot communicate with other IPs again. Okay. Similarly, 20 can communicate all the IPs up to 2255. It cannot communicate beyond that. Okay. So if you see there's a pattern here, 10 to 1255, 20 to 2255, 30 to 3255. Okay. Then 40 to 4255. And what do you observe commonly in this pattern, guys? In every network, you can connect a maximum of only 255 IPs, not beyond that. Okay. So 00 to 0255, that's 255 devices. 10 to 1255, that's 255 devices. To be precise, actually, it's 256 if I include the zeroth IP as well. But just to round it up, okay, I'm just saying 255. Okay. So in any class C network, the speciality of class C is you can only connect a maximum of 255 IPs, not beyond that. So in a small home networks or in small organizations, when you don't have a necessity of connecting more than 255 devices, when it's a small network, you only go for class C addresses. Okay. In my home network as well, I hardly have 5, 6 devices, not beyond that. So therefore, I'm going for class C. Okay. So each class is unique depending on the number of devices you can connect in each network. Okay. And class C speciality is you can connect up to a maximum of 255 IPs, not beyond that. Okay. Is that clear for everyone? Any questions or doubts up to this point? Satyajit, Tish, and Love. Right. Any other questions on others? And Srinivas, Tulsi. Srinivas, is this your first class? I don't recall
Yes, sir.
seeing
This
you
is
in
a
the.
first class, sir.
Hey, Srinivas, again,
Good evening,
apologies.
sir.
It might not make a bit sense today because, again, this is your first session. You've taken
Yes.
two other sessions before this, actually. First session was on the demo on what the course is about. And the second session, which was yesterday, was on networking fundamentals. And we're
Okay.
continuing that today. So don't
Okay,
worry, by
sir.
the
I
end of
will.
this class.
Hmm.
Sorry?
No, I
Yeah,
will
Srinivas.
continue, sir. I will take that
Yeah,
recording.
yeah. Sure, sure,
If I
sure. So
have
I'll
any
also
doubt,
show you where you can.
I will ask you, sir.
Sure, definitely. And I also share the recordings so you can access those as for previous sessions. Okay.
Sure, sir. Sure, sir.
Right. Oh, one more. I think there's one more
Thank you,
question.
sir.
Nothing. Okay, cool. So now when you talk about class B, guys, so class B specialty is it has two network portions and two host portions. Now, where does class B private IP started? 172.16.0.0. So class B has the private IP range 172.16.0.0. And this goes all the way up to 172.31.255.255. It's important to remember these ranges, guys. We have covered those ranges in the session yesterday, if you remember. Okay, so class B private IP range starts at 172.16.0.0 and goes all the way up to 172.31.255.255. Okay, and then class B now, the speciality is it has two network portions and two host portions. What does that indicate? So two network portions and two host portions. So the first IP is 172.16.0.0. Same pattern, 172.16.0.1, 0.2, 0.3, goes all the way up to 172.16.0.255. And now after 0.255, you have 172.16.10. Okay. Now in class C, whenever that 0.255 exceeded beyond that 10, the network divided there. But in class B, the network does not divide because even the third octet is the host portion. So this 0.255 can now freely communicate with 10. Okay. There is no restriction anymore here. Okay. So all the IPs from 00 to 0.255 can communicate beyond that, even to 10 as well. Okay. Where does this go up to? 172.16.1.255, then 172.16.20, then 2.255. This goes on and on and on up to somewhere down the line, you would have 172.16.2550, and then you have 172.16.255.255. Now, once both these octets are filled, then you have 172.17.00. All the 255s cycle back to zeros, and the next octet increments by one. And whenever there's a change in the network portion, when the 16 network portion changes to 17, the network divides over there. Okay. So now all the devices from 1600 to 16.255.255 can communicate with each other. But none of them can communicate with 1700 because it's outside their network. Similarly, from 1700 to 17.255.255, that's the next network. And after that, you have 1800. Okay. So any IP from 1700 can communicate with all the IPs under it up to 17.255.255. But beyond that, the next network starts. And from 1800 all the way up to 18.255.255, that's the one singular network. And after that, you have the next network from 1900 to 19.255.255. Okay, where does this go up to, guys? What would the last network be? So this will go on all the way up to the last IP, which is 172.168.255.255. That's the last IP. And where would that network start for it? Okay, so if that's 13.255.255, the network starts at 31.00. Okay, oh, sorry. That's the last network we have in between. Okay, so that's the speciality of class B. Now, how many devices can you communicate in each class B network, guys? So from 00 to 0255, that's the first 255 devices. 10 to 1255, another 255 devices. 20 to 2255, another 255 devices. How many times do we have those 255 devices? From 0 to 255. Okay, so that's like 256 into 255. Okay, if you include the zeroth network as well. But just to make it sound simpler, we can assume in class B, you can connect at least a minimum of 255 into 255 IPs. Okay, this is the first 255 IPs, then the next one, then the next one, then the next one, and that repeats 255 times. From 0, 1, 2, 3, 4, 5 goes up to 255. So for every third octet, you have 255 devices. And the third octet itself repeats 255 times. So 255 into 255. Okay, that's the speciality of class B. So when you have a larger network where you need to connect more than 255 devices, then you go for class B addresses. In practicality, it would have latency issues. You cannot connect those many devices, guys. But theoretically speaking, that's the possibility in class B. Okay. Oh yeah. Was someone asking a question? I could hear someone's mic unmuted. Yeah, love. Right. No, no, no. System won't choose. It's our own configuration. Love. If you want, you can go for class B and class A as well. It's your choice. There's no reason. Not really. You can do it yourself. The first time when you take an internet connection, the ISP guy itself chooses that class C, class B, or class A. But you have the control to change that as well. And I'm going to show you in today's class where you can change it. Okay, I'm going to say that. So there's no limitation, but it's a thumb rule that you should always only go for a class which is sufficient for your devices and not waste a lot of other IPs. Okay, so you can choose any class of your choice, but again, good networking practice is only to go for a class which is sufficient for your network size. Okay, and I'm also going to show you how do you change these classes in your network. Okay, sure. Moving on and finally come into class A now. Class A has one network portion and three host portions. Okay, and where does class A started? 10.0.0.0. So class A has one network portion and three host portions. Okay, and class A starts at 10.0.0.0, goes all the way up to 10.255.255.255. Okay, so now the last three portions are all host portions. So from 10.0.0.0, again, next you have 10.0.0.1, 10.0.0.2, 10.0.0.3, goes all the way up to 10.0.0.255. Then you have 10.0.1.0, which goes up to 10.0.1.255. Okay, then you have 10.0.2.0, which goes up to 10.0.2.255. Okay. The cycle keeps on repeating, and somewhere down the line, you have 10.0.2.550, which goes up to 10.0.255.255. And after that, you have 10.1.0.0.0. Oh, sorry, 1.0.0. Now, please note, even the third octet is host portion here. So from 10.0.255.255, after that, you can still communicate to 10.1.0.0 also, because all the last three octets are host portions itself. Okay. So from 10.1.0.0, this goes up to 10.1.255.255. Okay. Then you have 10.2.0.0, which goes up to 10.2.255.255. And you can notice they can still communicate with each other because all of these are still host portions only. And this goes on all the way up to 10.255.0.0, which finally goes to 10 255, 255, 255. Once all these three octets are full, then what happens? Then the network divides because now you have 11,000. Okay. So whenever the network portion changes, when 10 over here, this network portion changes to 11, the network then divides itself. Okay. But from 11, we anyhow have public IPs. So all of these are public IPs itself. Okay. So in one, class A has only one private network, and this entire range is one single network itself, which can communicate or accommodate a total of 255 into 255 into 255 devices. Okay, which is the largest of all. Okay, so that's the relevance of each class case. Class C is used technically since it's a smaller network size. You can use that for small networks, home networks, smaller organizations, etc., etc. If you want anything of a network size beyond 255 devices, then you can either go for class B or class A. It wouldn't make any difference because both of these are very large networks. Okay, so that's the relevance of private IPs in class A, B, and C. Class D and class E do not have any private IPs in them. All of them are public IPs itself. But these public IPs are kind of different. They're not given to the general public. We users, we normal public users cannot use class D and class E public IPs. We are not assigned those ever. These public IPs from class D and class E are reserved for special organizations, research and development organizations, military organizations, certain government portals, certain higher level secret service organizations, okay, RAW, ISI, FBI, etc., etc. All of those organizations have Class D and Class E public IPs reserved for them. Okay, Class A, B, C are the only public IPs which are assigned to the ISPs, Internet Service Providers, to provide the internet service, okay, or the access to the internet. Class D and Class E are not public IPs for internet. They're used by organizations specifically in these reserved categories. Okay, so that's the relevance of each class from class A to class E. Okay, is that clear, everyone? Any questions, any doubts up to this point? Srinivas, Satyajit, Tulsi, Sesh, Love. Any questions, please? Okay, perfect. Now, now that we know what each of these classes are, and now that we know why we are using each of these, let's move on to the next topic, which is subnetting or subnet mask. Okay, not subnetting, sorry. Subnetting is a much more in-depth concept and not required for our current syllabus right now. But let me explain what subnet mask is at least. Okay, so when you talk about subnet mask, this is for the computers to recognize which class is which. Okay,
One
now we,
second, sorry
oh
to
yeah,
disturb.
no problem, no problem. Go
Uh,
ahead.
is, is this IPs based on this? We can divide the zones. Is it based on this class? Based on that zones are dividing like
What zones are you
trusted
talking
zone,
about, Tulsi?
highly trusted zone. Okay, something like that. Is that nowhere related to this?
No, 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 not really, not at all.
Okay.
There's nothing as such, Tulsi. Although from public IPs, actually, we can figure out which region it is, though. Not about trust, though, but your entire internet's public IPs are provided by an organization called IANA, Internet Authority for Numbers Assignment. Okay, and that organization divides the entire world in 5 regions. These regions are called as RIRs, Regional Internet Registries. Okay. Oh, let me just search with that name. Regional Internet, yeah, Registries, RIRs. Okay. So your entire world map, if you notice, is divided in these 5 regions. AFRINIC for African Network Information Center, APNIC for Asia Pacific Network Information Center, ERIN for American Region Information Network Center, LACNIC for Latin American and Caribbean Network Information Center, and RIPE is for the Northern Russian, okay, or the Middle East region network center, okay. And each of these RIRs has its own set of public IPs, okay, and our ISPs get the public IPs from these RIRs itself. Okay, so Asia Pacific Network Information Center, this entire region, is going to provide. APNIC is the company which will provide the public IPs to the ISPs at that. So Airtel, Act Hibernate, Hathway, Tata Docomo, or Vodafone Idea, whatever ISPs exist here in our region, here in this subcontinent region and Australian region and all these other. smaller continents and islands, all of them get the public IPs from AppNic. Okay, and AppNic has a certain set of public IPs from it, which it will provide the public IPs to that region. So by looking at an IP, you can figure out what region it belongs to as well. Okay, but again, it has nothing got to do with the terminology that you have used, Tirmal. Sorry, Tulsi. Nothing related to trusted and highly trusted, nothing like that. Is that clear, Tulsi?
Okay, got it. Okay, yeah.
Right, right. Moving on. So coming back to this, let's talk about subnet mask. Because if you open up your command prompt, and in your command prompt, if you type ipconfig, we get something called the IPv4 address, our private IP. And under the private IP, you can see there's something called subnet mask. Now, what is this value and why do we need the subnet mask thing? Okay, so the subnet mask is for a computer to understand which IP belongs to which class. For us humans, we can differentiate with the network and host portions. Class A has one network portion and three host portions. Class B has two network portions and two host portions. Class C has three network portions and one host portion. But how does a computer differentiate between a network and host portion? So for that, what it does is it assigns the network portion bits with the value of 1 and the host portion bits with the value of zeros. Okay, wherever there's a network portion, you can see I've assigned all ones in that object. Wherever I have host portion, I've assigned all zeros. And when you convert that from binary to decimal, it gets to know the subnet mask for it. So for class A, with one network portion and three host portions, subnet mask is 255,000. For class B with two network portions and two host portions, subnet mask is 255,255,000. And for class C, the subnet mask is 255,255,255,0. Okay, so when your computer sees the subnet mask here in the command prompt, where did I think I closed the command prompt. So when I type ipconfig again, you can see the subnet mask is 255,255,255,0. So when my computer observes the subnet mask, it understands, okay, I belong to class C. This is my IP here. And I can only communicate with a maximum of 255 devices, not more than that. Okay, because in class C, the maximum number of devices you can communicate is 255 itself. Okay, so from a subnet mask, a computer gets to know which class it belongs to, what is the first IP, what is the last IP, and what is the entire range of IPs it can communicate with. Okay, and then you have something called default gateway. This is just another fancy name given to your Wi-Fi router. Okay, so the Wi-Fi router is always acting as a gateway between the two different networks, if you notice. Okay, so this here is my Wi-Fi router, and it acts as a gateway between the public network, the internet, and the intranet. So if any of these devices wants to communicate with the internet, they always have to send the packet to the default gateway, which is the Wi-Fi router here. Okay, hence it gets that name. Okay, now let's talk about how to assign IP addresses. So now that we know all the subnet mask, default gateway, all these properties, we need that information to assign an IP. Okay, and you can assign IP addresses, the private IPs to your system in two ways. One, you can either assign it manually from the control panel. Okay, or two, you can get it automatically from something called a DHCP server. Okay, so right now I'm getting it from a DHCP server. But if I wanted to assign it manually, this is the step-by-step procedure for it. Okay, in the olden days, if you were the network administrator for a company, it was your responsibility to configure the Wi-Fi router and to configure an IP address for every device in the network. Okay, so to every device, I have to open up the control panel, and in the control panel, I have to go to network and internet, and then I have to go to network and sharing center, and then I have to go to adapter settings. And in the adapter settings, I have to select which adapter I want to assign the IP for. So if I'm connected to the Wi-Fi adapter, I have to right click on that. I have to go to the properties. Okay. And then I have to go to IPv4 properties, Internet Protocol version 4 properties. And then I have to assign the IP. So currently, I'm getting it automatically, which means I'm getting it from a DHCP server. Okay. But if I have to assign it manually, I can go to the second option and I can assign the IP here. So I can manually type 192.168.0.10 or something. I can assign the subnet mask. What is the subnet mask for this IP? 255.255.255.0. Okay, since it's class C. And what is the default gateway? In my network, the default gateway IP is 192.168.0.1. Usually the first IP in the network is given to the Wi-Fi router. So I specify the same IP here, 0.1. Okay. Now you might have a question. This isn't the first IP, right? There's 0.0 as well. But again, please note, you never assign 0.0 or 0.255. These IPs are always called the network ID and the broadcast ID. So the first IP is always called network ID. This gives the identity for the network. And then the 0255 is called broadcast ID. I'll explain what broadcast IP is in a while. So this is called broadcast ID. So the only usable IPs you would have are the IPs excluding those two from 1 to 254. Okay. So that's why the router gets the first IP 0.1. Okay. And after that, you have to also assign something called a DNS server address. Now, if you don't know what this is, don't worry. You can just go to your browser and you can search for Google DNS server IP. And do not worry, I'm also going to talk what a DNS server is right now in a minute. Okay. But for now, if you don't know what the DNS server is, just copy this IP and paste it there. Oh, I think I'm getting a. Oh, love, I think your mic is unmuted. You're saying something? Oh, yeah, sure. No, no. There's no point of you changing an IP just in case if your Wi-Fi router fails to function. In that case, you need to know how to assign an IP yourself. Okay. So you need to know how to assign the private IP to your system, or if in the absence of a DHCP server, it's the responsibility of a network administrator to know how to assign an IP to every device in the network. Other than that, in today's world, you never have to assign an IP because your DHCP server automatically does it. Okay. And I'm also going to show you how that happens. Okay. This is only a case if the DHCP is absent. If you don't have a DHCP server or a Wi-Fi router in your network, then you assign an IP address. That's all. Okay. So this is I'm showing you how to assign an IP in that case. That's all. Okay. You don't need to manually change it ever. Okay. So when you talk about DNS servers, you can either type 8.8.8.8 or 8.8.4.4. So these are the two DNS servers provided by Google, if you notice. Okay. Don't worry, I'll explain what a DNS server is also in a minute. Okay. And as soon as I click on OK here, my system's IP will change from 0.5 to 0.10. But I don't want to do that right now because it might disconnect our session. Okay. So if you want, you can try this out later on, guys. No harm in that. Okay. And if something goes wrong, with just one click of a button, if you just select this first option and here also the first option, everything gets configured right back to the original state. Okay. So that is one way, guys. This is how you manually assign the IP. So you go to the control panel, you go to the network and internet settings, sharing center, properties, okay, and you change the IPv4 properties. That's how you get it manually. Now, in today's world, you don't have to do any of that because you have it getting assigned automatically from a DHCP server. Okay. So when I select this first option here, opt-in IP address automatically, opt-in DNS server automatically, my Wi-Fi router itself will assign an IP. Okay. But you might have a question. You told me DHCP server assigns it automatically. Why is my Wi-Fi router doing it again? So to show you a very simple answer for that, if I run a command ipconfig /all for all properties, you can see the DHCP server IP also. So my default gateway, which is my router, is getting the IP 192.168.0.1. And in my home network, the DHCP server is also the same device. Okay. So now in your all our home networks, whenever you have a Wi-Fi router, that Wi-Fi router also does the job of a DHCP server. Okay. And DHCP stands for Dynamic Host Configuration Protocol. It is basically used to dynamically or automatically configure an IP address, internet protocol address to every host in the network. Okay. And that happens with something called a DORA process. Okay. So your DHCP server has a pool of free IPs. Okay. If it is getting the first IP assigned to it, all the other IPs exist in a pool. And from that pool of IPs, it performs something called DORA and assigns every device a unique IP automatically. Okay. And now I'm going to explain what that DORA is. Okay. So to explain this in a very simple manner, let's take a diagram. Okay. So let's say this is my DHCP server here, which is also my Wi-Fi router in my home network. Okay. And this gets the first IP as mentioned, 192.168.0.1. And then it has a pool of IPs. Okay, so it can have 192.168.0.2, 192.168.0.3, 192.168.0.4. And this goes on all the way up to 192.168.0.254 and 255. Okay. So whenever there are devices in a network, let's say there's one device here and one device here connected. And in these devices, if you select that option, obtain an IP address automatically, then through the DORA process, your DHCP server will assign each of these devices a unique IP. So using DORA, okay, it'll assign this system the IP 192.168.0.2 and this system 192.168.0.3. Okay, and as soon as they're assigned here, they'll be removed from the pool. So the pool won't contain those IPs anymore because it shouldn't assign that same IP to another device. It'll cause a conflict. Okay. So now what is this DORA? So let's say I bring one more device in my network here now. Okay. So this is a new device, let's say. Okay. So the first thing that this device does when it is selected with that option, obtain an IP address automatically, what this device does is it starts sending a broadcast signal. So it sends a packet to this IP, to this IP, or basically to devices, actually not IPs, and to this device. Now you might have a question, how does that happen? So first thing, when you enter your Wi-Fi password on your device, okay, it gets something called a broadcast IP. If you remember, I mentioned that this last IP is called a broadcast IP. Okay, so this broadcast IP's job is basically that if you send a packet to this IP, it sends it to every other device in the network. Okay, so if you're sending a packet to the broadcast IP, it goes to every other device. It goes to 0.254, it goes to next one, it goes to next one, it goes to every other device in the network. Okay, and so in that way, the packet reaches to this device, and this device. And this packet is called the discover packet. So it is basically trying to discover who the DHCP server is. It's asking this system, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? When the device is not the DHCP server, the packet is just rejected. They don't respond at all. Okay. But when the packet reaches the correct DHCP server, that server says, hey, you were looking for me. I'm the DHCP server in this network, and I can now offer you an IP address. So an IP address is offered. Okay. So, and in this offer, it is going to assign or place an IP, a free IP. Okay. And for that offer, your client says, oh, thanks for offering me that IP. I request you that you don't allocate to anybody else in the meanwhile, and you reserve this IP for me. Okay. So a request is sent to reserve the IP. And for that request, your DHCP server says, okay, done. I acknowledge your request. And with that confirmation, this IP is assigned to your system. And that is the acknowledgement. Okay. And with that acknowledgement, this device gets the IP 192.168.0.4. And that is removed again from the pool as well. So from the pool, that IP is removed again. Okay. And this entire process is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. And I'm pretty damn sure you have observed this process at least once in your life. Okay. Whenever you connect your mobile phone or your Android or iPhone or any other phone to your Wi-Fi router, after you enter the password and click on connect, for a very short duration, you see this message, obtaining IP address. I'm damn sure at least once in your life, you might have observed that. Okay, if you're using a mobile phone, Android or iPhone, anything. Okay. So that process, when it shows IP, obtaining IP address, that is when the DORA happens. And once the DORA is done, it doesn't even take more than a second, maybe max to max 1 or 2 seconds. Okay. And in that process, once DORA is done and once an IP is assigned to your phone, then it shows connected. Okay. So connected is when your phone has gotten an IP from the Wi-Fi router and it is connected in that network. Okay. So that is when the DORA process happens. Okay. And this is how every device in your network can automatically get an IP from the DHCP server. And that's what its main task is, to dynamically or automatically configure an IP address to every host in the network. Okay. And if to show you this practically what it looks like, I can log into my router here. So I'm using a TP-Link router at my home. And if I enter my credentials here, This is the network Wi-Fi router properties. If I go to network and LAN settings, you can see my TP-Link router itself is acting as the DHCP server also. It's getting the first IP here, and then there's a pool of IPs here, as you can see, from 2 to 199. I've limited it to 199. If I want, I can change this to 254 also. No harm in that. Okay. And from that pool itself, you can see all of these are my home devices. Each of these devices is getting a unique IP. Okay. And beside the assigned IP, you can see there's a lease time. Okay. So that is the amount of time that IP is assigned to that device. After the lease time, if the device is inactive, that IP always goes back to the pool because there should be no wastage of IPs. If you assign an IP permanently and if that device is not available, so if this device is, let's say, not available, not in the network anymore, that IP should not be wasted. So that DHCP server has assigned that IP only for a lease time. After that time, if the device is not available, that IP comes back. Oh, sorry. This I have to remove. That IP comes back to the DHCP server. So 192.168.0.2 is available in the pool again. And when another device connects to that network, that IP is assigned again. Okay. So your IP is not lost every time you restart the system, right? Your IP is only lost if your system is inactive after the lease time. Okay. I hope that clarifies the question, Love. You asked me if the device, the private IPs are reset every time after system reboot. No, it's not reset after system reboot. If your system is inactive after the lease time, then that IP goes back and then you get a different IP after that. Okay. Right. So that is about the DHCP server, guys. And if you want to change the classes as well. So I think there was one more question. If I want to use class B or class A in my local private network, that also needs to be configured here. So I have to specify the address pool here. Okay, if I change this to 10 dot network, then I can use class A also in my private network. Since in my home network, I'm using it's a small network, I'm preferring class C. So when your Wi-Fi router is set up for the first time, the internet guy sets up this network. Okay. After that, if you want, you can change this. You can specify whichever pool you want here. And from that pool, all the devices get the IPs assigned one by one. But you have to enter the password again on all the Wi-Fi devices so that they get the new IP address from that pool. Okay. Is that clear, guys? Any questions or doubts? Okay. Satyajit, any questions? Sesh, any questions? Srinivas, any questions? Tulsi, any questions?
Yeah, just one question. So in
Yeah, Sesh.
IP pool, so we had to manually assign the IP addresses, right? So here,
Yes. Yeah. As mentioned, the first time when the Wi-Fi router is set up, the ISP guy himself assigns this pool. If you want, you can change that pool. You can change this to class B pool or class A pool. It's your choice.
and the lease time. So how determine this lease time? So manually we.
That is also configurable, Sesh. By default, it's
Oh,
always 24 hours. Okay. So again, as mentioned, you can put it anywhere between 1 and 2880. 2880 is 48 hours in minutes. Okay. So that is the maximum lease time available for my TP-Link router. So it is configured in the router itself by default. And I've set it as 1440, which is 24 hours. Okay. So that's
okay.
the
So
default.
so after suppose you assign your IP address to one of your laptop after 24 hours, if you don't use the IP address changes.
Yeah, if I don't
Oh,
use the IP goes back to the router, and in the
okay.
meanwhile, if that IP is taken up by another device, my IP will change after that.
Oh,
Although
so
if my device is active, my system will perform DORA again, right? And after the DORA, the same IP is assigned. That's the procedure.
okay.
Is that clear, Sesh?
Yeah, yeah. Yes. Thank you.
Okay. So lease time is only to prevent the wastage of IPs, guys. Okay. So in that 24 hours, as long as my device is active or inactive, that IP will be occupied. After that 24 hours, if my device is still active, I get the same IP back. If it is inactive, the IP goes back to the pool. And after it is going back to the pool, if there's another device in place of my device, that device might get that IP, which automatically means my device's IP will change later on, like once I reconnect back. Okay. So that's about the DHCP protocol, guys. Any questions, any doubts up to this point? a very simple and a straightforward protocol to make the task of network administrators easier. Okay, so you don't have to go to every system and assign an IP yourself. It is automatically handled by the DHCP server, okay, which is basically our Wi-Fi router in our home. In organizations, they have a separate server itself, a Linux machine running or a Windows server, which is also performing the job of a DHCP. Okay, in our home networks, our Wi-Fi router does that task. Okay, so that's about DHCP. Moving on to the next protocol and the last topic for today, okay, which is DNS, domain name system. Okay, if you remember when I was trying to configure a private IP in my network protocol page or the network setting page, you could notice it was asking us for a DNS server IP also. And I assigned something like 8.8.8.8 or 8.8.4.4. Now, what is a DNS server and why do we need it? Okay, what are those IPs 8.8.8.8 or 8.8.4.4? What do they signify? Let's talk about that. Okay, so to understand DNS servers in the simplest way possible, it is the internet's contacts application. Okay. Now everyone has a phone here, and in your phone there's an application called Contacts. What is the application doing? It is linking a contact number to a contact name. So as soon as you get my number, the first thing you do is you assign it a name and you save it in your phone. You assign it like Shoaib or Shoaib Cybersec or Shoaib Instructor, whatnot. Okay, any random name. Now, whenever you want to call up my number or when you want to reach out to me, the next thing you do is you don't remember the number, obviously. You search by the name, right? So you search for SHOAIB and then you hit enter, and then the connection is placed between your phone and my phone, right? A call or a message is placed between our both devices. Now, here, one important point to know is obviously it is not the contact name that is important, but to reach out to me, what is important is my contact number. Okay. So from your 10-digit SIM card number, a call is placed to my 10-digit SIM card number. The contact name is only for you to recognize who that number belongs to. Right. Similarly, in your browser, when you enter something like www.google.com, this is called a domain name. Okay, just like how you have a contact name, there's a domain name. But your browser doesn't understand this language actually. Okay. What it actually needs to connect to google.com is the IP address of Google. So your Google server is somewhere located on the internet with a public IP. And your browser is going to use its public IP to connect to Google's public IP. Okay. That is what the connection happens on. The name is only for you to recognize what that website is or who that website belongs to. Okay. The connection always happens internally on the IP addresses. And that linking between a contact name and a contact number is done like a contact application on your phone. Similarly, here, the linking between a domain name and its public IP is done by a DNS server. So the DNS server is the internet's contacts application or the contact book. Okay. So all over the internet with your ISP and with various organizations, they have DNS servers. And in these DNS servers, they are records linking every domain name with its exact public IP. So when I search for google.com, this request first goes to the ISP. And in the ISP, they have a DNS server. That DNS server knows, okay, google.com is located on so-and-so IP. So once again, this is the DORA process slide. Yeah, here is DNS. Okay. So when I search for google.com in my browser, that request goes to the ISP first. ISP has its own DNS server. And in that DNS server, there are multiple records. Google.com located on so-and-so IP. Bing.com so-and-so IP. YouTube.com so-and-so IP. Shrow.com so-and-so IP. So for every domain, they have a public IP linked with it. And with that public IP, once it gets to know that this is the public IP, then it reaches the corresponding server. Okay. If I show you an example for this, if I open up my command prompt and if I run a command ping is a command to check for connectivity, guys. So if I type ping and if I type www.google.com, I get an IP here if you notice. So I'm getting a reply back from 172.217.24.132. So ping is a command where you're using it to check for connectivity. Your device will send a packet of 32 bytes, okay? And it checks if it is getting a response or not, okay? So for every 32 bytes, the server is responding back with another 32 bytes, the ICMP response, okay? And if you're getting a response like this, it means the connection is perfectly fine. But if I copy this IP and if I go to my browser and if I paste this IP here, carefully observe what happens when I hit enter. I get google.com. Okay, so that is the actual IP that your browser needs, the actual address that your browser needs to contact Google. But we don't care about this IP. We don't need to remember it anymore because there's a DNS server internally linking that domain name with its exact IP address. Okay, so the linking between that domain name and that IP is done by a DNS server. Okay, so that is why we need it. It's called domain name system. It is linking a domain name to its exact IP address, and that entire system is what is making the internet an easier place. Okay, it's easier for us to remember names rather than numbers. Okay, and that's why DNS servers help us connect to the actual websites in the background. Okay, and one more thing that I wanted to speak about. What was that? I forgot. Hmm. Okay, anyways, but yeah, that's what, again, just like how we have a contact name and a contact number in the contacts app, on the internet, we have domain names and IP addresses. Okay, domain name is like the contact name, and this IP address is like the contact number. And that linking is done by a DNS server. Oh, yeah, what I wanted to talk about was this one, Google DNS server. So when we, again, if I go back to my command prompt, okay, and if I type ipconfig/all, this is the current DNS server that I'm connecting with. So these are my ISP servers, okay, internet service provider, and these are their DNS servers that are configured. Okay, so when I'm taking my internet connection, they're also providing me DNS servers. But just in case, if I don't know my DNS servers, I can always go and use Google's DNS servers also. Okay, Google has these two servers, one on 8.8.8.8 and another one on 8.8.4.4, and these are public DNS servers. Okay, so anyone can use Google's DNS for free. Okay, they have hosted it publicly. Anyone can access them and access all the records that are available on Google DNS servers. Okay, so just in case if you're configuring your own network and if you don't know what DNS servers to use, you can freely use Google's DNS servers. Okay, so that is the last topic for today, guys. There's one more concept called special ID IPs. We'll cover that in the next class. Okay, but as mentioned, today is the last demo class, guys. No more demos from tomorrow. To continue further ahead with these topics and the other upcoming cybersecurity classes as well, you have to register with your respective institutes. Okay. So this is the last demo. We have been taking demos from Sunday itself. We have taken the same demo on Monday and Tuesday, and Wednesday and Thursday we have taken the networking fundamentals, the prerequisite for cybersecurity. So if you have not registered already, please do register. From tomorrow, the link will change. Okay. And on that link, you will have access to the classes for all the registered students. Okay. Any questions or sorry, any questions or doubts up to this point?
What is ISP, sir?
Oh, just a second. There's overlapping voices. I'm so sorry. This issue will be resolved from tomorrow. Someone else was asking a question before that, before love. What is what?
Before you showing that ISP.
ISP is internet service provider.
Okay.
Airtel, Act Hibernate, Hathway, Vodafone Idea, Reliance Jio. All of these organizations are providing the service of internet to you. They are called as ISPs, internet service providers.
Sir, Monday, Tuesday, what what classes happen, sir?
Monday, Tuesday, we covered the cybersecurity demo, Srinivas. What again? I'll explain that in the end. Don't worry. I'll also share the links with you to access those sessions. Okay, just give me some time for that. Okay, I'll come back to that. Other than that, any other questions, guys? Any technical questions from today's class? Yeah, love. You were saying there was a question on your end.
Sir, IT is too bad now, so nowadays after January, any
Srinivas, 1 second. Yeah, and there's some other students on another link as well, so you're not able to hear their questions. The voice is overlapping up. I'm so sorry, Srinivas. I'll come back to you in a minute. Yeah, love, you're saying? Google has its own public. Yeah, yeah, definitely. To host its own website, Google definitely needs its own public IPs on those IPs. Mhm. Yeah, definitely. Every web page on the internet, every company will have their own websites. Websites and respectively their IP addresses. Love. Now the question is, are you hosting it yourself or are you hosting it through a third-party hoster? So there are companies like GoDaddy, Big Rock, Hostinger, etc., etc. Now, one thing is you can take the public IP from these ISPs, from your internet service providers, and you can put your own server, and to that server you can assign your own public IP taken from the ISP. Alternatively, you go to a company like GoDaddy and you tell them, I want to host this website. I'll just give you the web pages. You host it on your server and you also provide the public IP only. So that is another case, okay, where the IP is provided by that hosting company. The server, the entire infrastructure is provided by that company. All you're doing is you're just hosting your web pages on their servers. You're providing the web server, your websites, pages, and you're paying them some amount of money every year, okay, to host your website. On their servers, exactly. Yeah, they'll provide the IP. We don't need to worry about that. Yes, right. Yeah, Srinivas, you were asking a question. Love, if you have no questions, we can disconnect here and I'll connect back with you after this in a call. Sure. Yeah, so just a second.
Sir, class timing is 8 o'clock, sir.
Yeah, Srinivas, I'm so sorry. Yeah, every day from 8 to 9, we have the sessions, Srinivas. And to come back to your point, just a second, let me stop the recording as well. To come back to your point, these sessions are being recorded, Srinivas. You can access them from the official DurgaSoft YouTube channel. So if you go to your browser and in your browser, if you
Yeah.
just search for DurgaSoft cybersecurity,
Okay, sir.
if I go to YouTube here and in YouTube, if I search for DurgaSoft,
Mutsana madam shared, sir, already.
who shared?
Madam, that front office madam, Mutsana.
Oh, Muskan. Okay, okay, okay. Right. Perfect. So again, yeah, I think this, as you can see, these are all the seminars which I conducted. So this is the, where is this? I have to filter it by recently uploaded. And these are all the classes, 4 days, 2 days ago, as you can see. Okay, these are all the classes I conducted, demo 3. Okay. And today is demo 4. Okay.
This
So
is the
these,
fourth class, sir. Fifth
yeah,
class.
this is the 4th class today.
Okay.
Uh, Srinivas, sorry, forgot the name there. Okay. So the classes are from 8 to 9 every single day, from Monday to Friday. We have classes for 35 days of duration, and all these sessions are being recorded. And once you register, these recordings will be provided directly to you on your Google Drive. You don't have to search for them on YouTube. Okay. And you'll be getting the presentation documents, you'll be getting the notes, okay, everything for the price mentioned by the organization, by the institute there.
Course duration, sir?
35 days, Srinivas, 35 to 40 days.
40 days.
Any other
One
questions?
question, yeah.
Yeah, please go ahead.
The domain name, once we purchased, maybe public IP also, okay, we need to register with the DNS servers or automatically when the ISP is providing IP, how the linking can be happen to the DNS servers?
Yeah, the DNS is handled by the hoster itself. So when you're purchasing a domain from GoDaddy, Big Rock, Hostinger and all, they will itself
Yeah.
have their own DNS servers and they link your your domain with their IP addresses. They maintain the DNS records themselves. If you're not
That
hosting with
means only
third party,
DNS if you purchase, you don't have to purchase any public IPs?
not required. You're not purchasing any public IP at all. You're only giving them the money for hosting your website. So you are purchasing the domain there for a certain price. And after
For
purchasing the
example,
domain,
I
you'll
don't
pay
want
them
to
for hosting
host
your website.
those.
Sorry.
Yeah. For example, I don't want to host their site. I want to host it by myself. In such case,
In that case, you'll only take for the DNS records. So you're purchasing the domain, right? After you purchase the domain, you'll supply whoever you're purchasing the domain with. They'll put your information in their DNS servers itself.
okay. The IP, public IP, we don't need to purchase. Only domain
You
name
don't.
itself.
No.
Yeah.
If you're hosting the IP for your web server, right? That IP needs to be purchased. You don't need another IP for your DNS server because that DNS server is handled by the hoster. If you don't want anything from them, you can purchase your own public IP for your web server. You can purchase a separate public IP for your DNS server and maintain 2 separate servers.
Okay. The DNS can be handled by majority of the cases by this ISPs and the GoDaddy, the domain
And the
name
DNS.
service providers,
Yes,
right?
domain registrars, exactly.
Okay. Okay, got it.
Yeah, okay. So if I show you an example for that, we'll see. Now I have my own website called Hackers Demi. Okay. So this is my
Okay.
own cybersecurity web page here. And now what I've done is I've purchased that domain from Cloudflare. Okay. So in the Cloudflare now, oh, 1 second. I have to log in here. Yeah. As you can see, this is my account here. And this is the domain that I've purchased. Okay. And once I've purchased that domain from them, I've paid the amount for the domain. I've paid the domain amount for the hosting as well. So they're also hosting my website. Okay. And once they host it, they are maintaining the DNS records also. So if I click on records here, these are all my DNS records, the main record, the A record, as you can see. So this is all handled by them itself. Okay. This is my website and this is the IP address for it. And this is the A record linking a domain name and its public IPv4 address. Okay. So that entire DNS record handling part is done by the hoster itself here. Okay. So I don't need to purchase anything. I'm just purchasing the domain and I'm paying them certain amount of money to host the website on their servers. Okay. So that's the only thing required there. So Cloudflare is handling all my DNS records and hosting my website. Okay. Cloudflare name servers. Name servers are nothing but the DNS servers itself. Okay. Is that clear, Tulsi?
Got it.
Right.
So what actually is the DNS records means and what in the
The
content?
linking, the linking, Sheesh. So if I just show you, this is what as I was showing the records right now.
Yes, those
So
records.
yeah, record is the linking between the IP and the domain. So just if that linking is not there, when you enter that domain www.google.com, your browser doesn't know whom it should contact, what server should it reach on the internet. So that linking between the domain and the IP is the record. So as you can see, if I go to the records here, my mail
Mhm.
server, sorry, my name server. Okay, so I hope this website here,
Mhm.
hackersdemi.com, is linked
Yeah.
to this IP. So this entire line you see is called a record. Okay, this is an A record linking the domain name to the IP. Similarly, if I have a mail server, okay, that mail will have an MX record. So this MX is for mails. Okay, so my mails are being routed to Cloudflare. So this is the host name of the mail server, and this is the domain name. And internally, it has an IP also, and that IP and entire linking is done by that mail record, MX record. Okay. Similarly, there are other records for other different servers. Okay, so each of these is a record linking a domain name to its exact IP address and vice versa. Is that clear, Fish?
Yes, clear.
Right.
Like one thing, like this is our question. So when you request like a website, like when I type the address something google.com,
Uh-huh.
you said it first goes to the IPS, right?
ISP, Internet Service Provider.
ISP,
Yes.
sorry, ISP. So
Right.
without knowing ISP, we cannot access the web address. Web.
No, no, no way. You can't because that connection, that public IP you're getting is coming to you from the ISP itself.
So
Right, Fish?
whatever we type, it has to go to the ISP.
ISP. Definitely. Definitely.
Oh, so there
Unless
is no
and
masking.
unless and until you're using something called a VPN. Okay. So in the VPN, you are able to mask your data there. So it still goes to ISP, but after the ISP, it doesn't know what website you're visiting after that. So from the ISP, it then reaches to VPN server, and then from the VPN server, it goes to the target website. So if you're using a VPN connection there, then you can mask that information.
Okay. So after ISP,
Yes, after ISP itself. Your ISP
but
will
we
definitely
cannot
get to know
mask
that you're visiting.
ISP.
No, 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 no way. There's no chance.
Okay. Okay.
Right. So there's a concept called spoofing class actually, Sesh. If I show you that documentation also, just a second. So that's the
Okay.
topic we'll be covering later on.
Oh,
Mm, Spoofing. Yeah, this is the next concept actually. So this is where I'll show you how to mask your public IP, how to mask your again through VPNs to web-based proxies, how to mask your MAC address to hide your device identity. Okay, how to change it completely over the internet. We'll cover all that in this topic actually, called spoofing of
oh.
IP and MAC addresses. So there I'll explain what VPNs are, how they are working, and how they are masking your identity over the internet.
Yeah, recently we are hearing like a masking the airports, Delhi airport, something like that. So,
Masking air, I think that's a different concept altogether, Sesh. But here, what we're talking about is hiding the device identity. So when an
oh,
attack occurs on an organization, attacker won't use their own exact public IP. They won't use their exact MAC address. They'll completely change it. So if I'm a person using this internet connection from India, on the target server, it will show as if I'm from Russia. Okay, they'll get a Russian IP and they'll get a completely different device information also. So even if I'm
oh,
using a Windows laptop, I can make it show as if that is a router or that is a Mac system or that is a database or anything. Okay, so that is what I meant by spoofing or masking.
oh, okay.
Right. Any other questions, Sesh?
Yeah, yeah. Thank you. That's all.
Yeah. Okay. Again, as mentioned, Sesh, this was the last demo. If you've not registered already, please do
Yeah,
register with your
thank you,
respective.
absolutely. I already talked to the staff.
Okay. 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 Perfect, Sesh. We'll connect back tomorrow then.
Yeah.
Okay. The link will change, Sesh. So that link will be provided once you register. Okay. So
Uh,
not the same link. You'll be getting a new link from the institute.
from tomorrow, the class starts, right?
Yeah, from tomorrow itself. We are continuing
Yeah.
exactly from where we left off today, but only for
Mhm.
the registered students.
Yeah, yeah, yeah.
Right. Right. Thank
Okay. Thank you.
Thank you. Bye.
Yeah, that's all.
Take care.